Ladies and gentlemen, please take your seat. The next agenda is welcoming speech will be given by Dean of the Faculty of Mathematics and Natural Science, Professor Dr. Devi, MSc, PhD. To Professor Devi, please welcome.
Warahmatullahi wabarakatuh. Alhamdulillah wa syukurillah wa la haula wa la quwwata illa billah. Selamat pagi, salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan. Honorable Vice Rector of the University of Jewel, Professor Bambang Puswadi, Honorable my distinguished guest, visiting researcher in Faculty of Mathematics and Science, University of Jewel, Assistant Professor Dr. Swaminathan Venkataraman. It is from Sastra University, India. Welcome to our main campus, the University of. We will stay here during 1 month. Hopefully, can have a good collaboration, especially in research. And it is working on combinable and graph theory, especially in visiting me, the research group of SIDAN, as well as mathematics of FMIPA University of Jeddah. Right now, we have a lot of concern about the application of graph theory, especially in nowadays disruptive era. As we know, the top 5 of disruptive era of technology. The first one is Internet of Things. We have already used this one for maybe 3 years ago. And the second one is artificial intelligence. The third one is CUI, user interface, by using a machine learning. And also we have online business, and the latest study is the rest of the existence of big data analysis. And this special issue, we use a graph or hypergraph in the application of this concept to solve any complex problem. Swaminathan Venkataraman came to this university. He bring a very latest study, very latest research of interest, especially in social network and biological network. He already discussed with me about DNA analysis, DNA engineering, for the future life by using Hypergraphs. Now he will talk about this. So please, all participants, please be noticed and please have a good discussion and ask something to him if you don't understand properly, because you are more benefit than the other one. Almost 50 participants I saw in the Zoom meeting. So on behalf of the Faculty of Mathematics and Science, I would, would like to thanks to Professor Bambang Pandit who persistently support us. And then we have Professor Swaminathan here. And hopefully it will be have also Dr. Stalin, maybe short future. Nice to have online meeting with him because the Department of Chemistry also need to have a good discussion with the international study. Again, thank you, Professor Bambang Swati, as a Vice Rector of this university. And again, thank you for your time, for your visit, Professor. That's all for me. The focus discussion session. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much to Professor Ravi for the welcoming speech. The following agenda is opening speech as well as open this event formally will be given by Vice Rector of Planning, Operation and Information System, Professor Dr. Andes Bambang Kuswati, MSc, PhD. To Professor Bambang Kuswati, please welcome.
Good morning, all of you who attend this lecture. First of all, I would like to thank to Professor, Associate Professor S. Venkatraman who visit our university as part of his project on G20, right? And it is also our initiation to make collaboration with Sastra University in India. Hopefully, later on we'll make some draft on the MOU. And also, Honorable Dean Professor David, who created this wonderful event during his visit, Professor Travel visit to University of Jember, and also other participants who attend this conference via online and offline. Hopefully, we will get some new idea, and also later on we will more on practical work as well as on the collaboration as I said earlier. Hopefully, this with lecture on to make sure that the title is correct. Social and biological network analysis within the program, and Dr. Kantama also will talk about live algebra and application as well as development of soft computing technique for text summarization. Hopefully all these issues will be useful for us, particularly for students who attend this, either undergraduate or master, or even PhD student who attend this quiz lecture, if online or offline. Hopefully it will be useful for us. And as representative of University of Jember, again, I would like to thank Prof. Venkatraman as well as the Dean of the Faculty of Mathematics and Mathematics, who create this case lecture. Only the actually in this visiting, actually we already invite two researchers. First is Professor Dengan Raman already will to speak after this, and the other is Dr. Stalin from Biochemistry Department. Hopefully, will be next collaboration. We'll have Dr. Stalin we'll talk on the biochemistry as well as on biosensor, which is similarly very but Professor Venkataraman related with Professor David, so that later on the discussion will be hopefully will be more fruitful for both sides, either with September as well as to Sastra University. By reciting Bismillahirrahmanirrahim, as I asking for the MC to open this lecture, by saying Bismillahirrahmanirrahim, I open officially this lecture. Bismillahirrahmanirrahim. And again, hope all the participants will follow all the lecture for this event, and then later on we will have discussion either through the online or offline in this class, as well as maybe possible collaboration like student aging, so that one day we will also visit Sastra University in India. And then, last but not least, I hope all the participants will have new idea from this lecture and discussion and on. And I ended my speech by saying Assalamualaikum warahmatullahi wabarakatuh.
The following agenda is given purpose of appreciation.
No, no. Oh, es mía, Robo, ¿verdad? Es mía. And thanks for all the arrangements. Thank you so much. In the middle, right? Okay.
Thank you very much to Professor Bambang Kuswandi for the speech. Entering the next agenda, there is reading of prayers by Bagus Julianto, SSE, MSc. To Mr. Bagus, please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan na'imin, hamdan yu'min ni'matahu wa yu'ti masida. Ya Rabbana lakal kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. Allahumma sholli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Rabbana ighfirli wa li walidayya وللمؤمنين يوم يقوم الحساب اللهم إنا نسألك نعمة ورحمة وحسن الخاتمة اللهم بارك لنا في أمرنا اللهم بارك لنا في رزقنا اللهم بارك لنا في علمنا اللهم بارك لنا في علمنا اللهم بارك لنا في علمنا يا الله يا رحمن يا رحيم يا عزيز يا غفار يا فتاح يا رزاق يا حي يا قيوم يا ذا الجلال والإكرام ربنا هب لنا من أزواجنا وذرياتنا قرة أعين واجعلنا للمتقين إماما ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much to Mr. Bagus. The following agenda is second documentation. For the offline participant, please come to in front of. And for the online participant, please turn on your camera. Ladies and gentlemen, entering the main agenda, there is speech and guest lecture by our honored speaker, Professor Sominatan Venkatraman. This session will be moderated by Abdul Rizki SSE MSc. Ladies and gentlemen, please welcome our moderator, Mr. Abdul Rizki. To Mr. Abdul Rizki, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Vice Rector of Planning, Corporation and Information System, Professor Dr. Anand MSc, respectable Dean of the Faculty of Mathematics and Natural Science, Professor Dr. MSc, the Honorable Rector of the Mathematics Department, and the Honorable participants of this lecture. Ladies and gentlemen, I am Kristi, the moderator of today's lecture. I am very pleased to see you here and welcome all of you to this event. Today's lecture is about social and geological network analysis using Hypergraphs. Ladies and gentlemen, our speaker today is Professor Swaminathan Venkataman. Allow me to read his curriculum today. Swaminathan Venkataman is undergraduate and postgraduate degrees in mathematics from Bharati Dasan University, Master of Philosophy in Mathematics from Fellow Institute of Technology, the PhD degree from Sastra University and India. In the academia from year 2000, researcher in pure and applied mathematics, published a number of articles in the area neophys, closed space, and their application and implementation of intelligent techniques with algebraic and hypergraph components. Research interest include non-commutative algebraic structure like algebra, lattice, triple system, closed space, hypergraph, and interpretation of intelligent technique with applicable mathematics for science and engineering goals. Artificial intelligence contest 2022 final winner conducted at Sastra University awarded Sastra into G20 and professor in 2023 by Sastra University and included by the design and development of diagnosis application and device for a comprehensive explanation with the desktop having a camera or laptop and practice it to use chronometer and the facility operation to understand agent addressing the subject of specialist available to provide the expertise on the global level also can assist ophthalmologists and optometrists for further diagnosis. As delivered in part of in several nations and international conference and research person for workshop. Is a reviewer for some reputed international group. Before the presentation begin, let me inform how the presentation will be going on. First, Professor Swaminathan will be invited to present the material. After that, there will be a question and answer session. To deliver his presentation to Professor Swaminathan, the floor is yours. Thank you.
Mostly files were there, copies.
You can, the Zoom. Is visible.
Yeah.
Don't agree. Yes.
Good morning, everyone. Oh, yeah. Okay. I'm Swaminathan Venkataraman from Shastra University. Our university is in India, southern part of India. It's deemed to be university. As a part of G20 held in India in 2023, our university has selected 20 professors from various disciplines, and we are allowed to stay in our partner universities for a month. As a part of this program, from Faculty of Mathematics, I have been selected with the grace of Vice Rector and Professor Topic. I could visit University of Jambal in this December. First, I would like to extend my sincere thanks to Vice Rector Professor Kusmandi and Professor Taufik for grazing such instruments. Thank you so much, Professor. So ours is a university with more than 15,000 students and 1,500 faculty members. We have around 15 schools, more than 150 programs we have. So we will come to all these things little later. Now, the topic of today's discussion is social and biological network analysis using hypergraphs. So let us try to understand why do we need network analysis. So first point, as Professor told, IoT we are using and many other networks, knowingly or unknowingly, we are using them. We are going to list out some of the networks and how we are going to analyze them in the following slides. So networks which software you are using? Is it PDF or what? Adobe or what you are using? Whether you are using Adobe or Foxit or what? Hmm? PD? Vitro. There will be a option for one page at one side. Yeah. Not continuously. Yes. You can zoom out. Now it is moving one page, right?
Yes, yes. Because we out here is online. It's
Yeah. Yes. No, some settings is different. Now they are getting. We can come to the next page. Well, all these networks are created due to the relations. When there are more entities or objects or human beings or any type of elements, we easily represent using the graph theory with vertex that we know all. In this representation, there may be some relation between some specific vertices or set of vertices. So these relations forms a very important concept, and also we need to study these relations. We normally represent the relation between any two vertices or nodes with an edge, otherwise we call it as R, that we know already. So when some nodes are related, connected, we need to know the nature of the relation, and we need to study the properties of such relations. And for the better use of network, we need to analyze it. So, such networks will exist in many cases. For example, social networks. Social networks arises when we want to analyze a network of Facebook, Twitter, uh, many such social media. Sometimes we need to know the citation tree also. How many citations already we have, how the citation expands. So for all these things, we can make use of networks. In case of biological science, there are plenty of networks which are required for us. We need to analyze, we need to first construct, we need to characterize, we need to analyze, and based on the analysis, we have to use it. We will be using it for many purposes like medicine, design of medicine, how to, we can find out how disease is really spread. How, what type of diseases could be the end, at the end we will be getting because of any protein interaction and so on. So these type of networks, social, biological, and we have many others. So these type of networks will have to be used for many purposes. And besides inside the structure, the dynamics works, and complex behavior of networks also can be easily studied. Like this. We all know very well that the entities or objects are denoted by nodes. The relation between nodes will be represented by areas, and when we combine both nodes and we will be able to design a graph, and we need to analyze different types of relationships. Some of the important relationships which we need to analyze will be like ties, genetic interactions, biological, metabolic pathways for various area of biology, protein interactions for analyzing the cause and reactivities, many more. The primary used is given as metrics or central issues. They arise from the graph itself. Many are there like cycle signature, fitness, clustering coefficient, modeling, influence, and many more. So all these could be used from the data, from the graph itself directly, and will be using it for analyzing the network. When we are talking about the graph theory, we have certain limitations. Uh, Important limitations is the representation of relationship. these graphs, a binary representation is more effective. Mean to say that binary represented entities, that is, these are entities that are having only binary relationship, will work very well. You can make use of graphs to the maximum extent, and it could be represented better by the graph. Uh, we can uh, take decisions to control certain decisions. But you have another, that is the station which are having more than, which are having more than two entities, three or more entities. Then graph will be having some problems. In the sense that the complexity, that is the working um, time, will increase to the maximum extent, because we may have to include more and more edges to represent the complete system. So the complexity will be more, and in this case, the difficulty of understanding the structure also will be increased. Similarly, when we have large graphs, uh, the number of edges will be much more. So the large networks will be having the scalability problem. If you want to find the decentrality, then we have to go for a large computation, and sometimes we may not be able to complete the centralization or organization. Also, we have some other problems like combining heterogeneous data. If the data is homogeneous, then obviously it's very easy for us to handle. But in nature, the data is mostly heterogeneous. So handling heterogeneous data also will be more difficult in this graph theory. The last but not least, the noise. Any data naturally will contain noise. And in most of the cases, there will be a big uncertainty component in the data. So handling this uncertainty and noise also will be a very big challenge when we are using graph. So to overcome these problems, mathematicians have devised the generalization of the graph, and it is known as hypergraph. It has the meaning we hyper the vertices into the edges. Hyper, we are putting more number of vertices into the edges, and so the edges here are known as hyper edges, and the graph that is having hyper edges is known as hypergraph. So that is the naming because of the meaning. Anyhow, so these hyper edges can consist more vertices, any number of vertices I can say. So because of this flexibility, we are able to easily model the higher order relationships. So that is the biggest advantage of hypergraphs. So we are able to express the entities and their relations very clearly without missing any information. And because of this, we are able to capture uh, multimodal data, multidimensional data, and with the development of various theories in hypergraph, we are able to analyze higher order structures and the scalability and performance also will be increased with the hypergraphs. Because of all these reasons, the interpretability, decision making, and the insights of the structure will be very clearly predictable. So with all these in our background, let us try to understand what is hypergraph. It is also basically pair. We write it as VHD, EHD. HD represents hypergraph. We all know it is vertices. E is going to be edge, back here it is going to be hyper edge. As I told you, vertices to be hyper into the edge, and hence it is hyper edge. So the graph that contains hyper edge is hypergraph. Vertices are similar to what we have in case of the graph, but the edges are basically EJ, they are the subsets of VHG, that is the set of all vertices. So with every EJ is a subset of VHG. We know very well that if we talk about subsets, then there will be 2 power n subsets for any set with the cardinality n. Suppose a set has n elements, then the number of subsets will be 2 power n. The strength of hypergraph lies in the subsets as well as the weakness, because the number of subsets for any state which you know is 2 power n. So it increases exponentially. So exponential increase will increase the exponential complexity of any problem, and this is not desirable for us. So when we work with hypergraphs, we need to control the number of edges effectively. Otherwise, we get into exponential growth algorithms. Yeah. Reserve for information, as in the case of graphs, we have, all right, any hypergraph will also be standard graph. As I told you, it is a generalization. Hypergraph is going to be a generalization. So it becomes a simple standard graph when every edge will contain one or at most 2 vertices. So if it goes more than 2, it becomes hypergraph. In the case of hypergraph, also we have directed hypergraph. The other one is undirected, which you already. Many representations require undirected, as well. So many representation requires directed graph. Now, the directed hypergraph, as I told you, if you take one edge, say E1, it has 4 vertices, actually 5 vertices. Sorry, E1 will be having 4 vertices, V1, V2, V3, and V4. But in case of directed graph, we define the edge using head and tail. For E1, the tail are V1 and V2, whereas head will be V3 and V4. So we just denote by T of H of, this is tail of every hyper edge and the head of every hyper edge. So the previous one which we have seen in the undirected graph, the relation will be multidimensional. Here it is directed graph. Here also multidimensional, but the direction must be considered in case of directed hypergraph. Similar to that, we can have a weighted directed weighted directed hypergraph, weighted undirected hypergraph, unweighted directed hypergraph, a simple undirected hypergraph, all those things. These are very important for many occasions like labeling and accessing many networks. In case of directed hypergraph, we have again DRs and EFRs. Okay, why we are just getting into the directed hypergraph here? Many biological structures and some of the social networks also requires direction. I can name many of them. We will be discussing some of the directed hypergraph structures, directed entities with represented by hypergraphs, and we will be making use of them. We will be analyzing it, and we will be able to get some conclusion also. Now coming to BR, that is backward hyper. This backward hyper R will have the head one, only one head. The tail may be any number, as against FR. In this case, head may be any number with a single tail. So single tail will be FR, and a single head will be having BR. So with this, we are able to define B hypergraph and F hypergraph, where all the hyper edges are BRs, then it is B hypergraph, and if all the hyper edges are F, then it is F hypergraph. In most of the cases, we will be getting BF hypergraph, both backward as well as forward, because natural phenomena will be having both backward as well as forward. Now coming to the first network, that is social network. So as we discussed already, they represent relationship, and they represent relationship between individuals or groups. When there is a relationship between individuals, graph will do nicely. Whereas if there is a relationship between the groups, then we have to go for a hypergraph for better understanding, for better analysis, etc. That's why we need, sometimes we need to discuss or we need to analyze the friendship, collaborations, information exchange, all these things. So, as told already, this could be used for analyzing Facebook, Twitter, LinkedIn, and many digital platforms. I hope you know very well why we need to analyze all these things. So, if any, for example, LinkedIn, they want to promote their network, for which they want to give the required information to their users. How do they find the required information? How do they know that I need this particular information or something related to any specific part or anything like that? So we need to make use of network analysis, and based on the network analysis, we will be able to find their requirements. Also, we need to understand the social dynamics through social network. The social dynamic in the sense that the spread of information. Suppose we want to spread one information, then to whom we have to start, from where we have to start. And if you don't want to spread information, where it could be done? So these type of things, dynamics. For this, we need to analyze hypergraph network. As I told you already, marketing and advertising. Suppose any company want to have more advertisement in less time and less effort, we need to analyze it. Like tracking disease spread. This is another important concept that may be required at times. That has to be done by the government, individual, or any society, any body, etc. So for those things also, we need to know which node is more influential, so that if that node receives the information, that would influence maximum number of people or maximum entity. So that is another important application of social network. So studying cultural norms, social structures, and group dynamics also plays a vital role in sociology and anthropology. So some of the examples I had given here, like friendship network, connection between individuals based on personal relationship and interaction through any social media. In online social networks, which already we have discussed, like Facebook, Twitter, etc. So now our objective is to uncover the hidden community structures and influential and non-influential users within any digital platform. So here we have taken Facebook friendship network. We are going to make use of certain measures, what we call it as centrality measures, for the analysis of such networks. There are more than 40 centrality measures that are very active for hypergraphs. Many of them are taken from the graphs and it has been modified to suit to the hypergraph. And some of them we are going to use here just only four. The first one is givingness centrality. The second one is closeness, harmonic, and eccentricity. If you look at these centralities, you can see this is the whole sum of the distance between S and T to U by the all possible paths. Similarly, we can define closeness centrality. Here it is going to be the numerator n minus 1, number of vertices minus 1, whereas the denominator will be the sum of distances between the specific vertex and all other vertices. Similarly, we have harmonic centrality, which is similar to this with some modification, and eccentricity is going to be the maximum of distance from U to any V. Suppose we have a simple social network which consists of A, B, C, D, E, F. One CPE is just given here for the better understanding. And for each and every node, we have all the centrality measures here. We can easily see that the degree centrality is simply number of edges. So if you look at it, except B, all other nodes has 2. So we may not be able to come to any conclusion based on this. So we need to go for some other centralities. So we have gone for BC, CCHT, and EC. We can see that B is 1.33, D is 1.83. So we can see that D is more influential than B, but it is hidden here. This is what is our idea. So from all these centralities, we can easily see that B and D has more values, so they are more influential. So if you look at the graph, we'll be able to decide only B is more influential, but it's not the case. D is also more influential. So this type of analysis is much required for the decision of the execution, for the decision of execution. So, the another beautiful concept in Hypergraph is ties. So let us define some of the ties. The weights of the node incidence with the corresponding hyper edge is weighted node degree enthalpy. So that is given in the mathematical expression. It is simply the sum of the weights. So what can we do with this? We will be making use of many concepts along with this weighted node degree centrality. We will be able to find the weak ties and strong ties. Here, a simple statistics have been used. It is nothing but mean and the standard deviation. So if the mean plus standard deviation is less compared to any specific node, then it is classified as strong tie. Similarly, if the sum of standard deviation and mean is more than a specific node, then it is known as weak tie. So weak tie in many cases are preferable. Similarly, the strong ties also are preferable. So before going into that, as I told you, we can make use of many other concepts. We can make use of other statistics. We can make use of distributions and many more for the decision. We are fixing a line, control line, say like. So if it goes above, then it will be strong tie. If it goes below to that, it will be known as weak ties. Now, these weak ties are required at many cases, and strong ties are required for many cases. The weak ties are required for more spread, whereas the strong ties will not have more spread. So, if you need more spread, we need to go for weak ties. On the other hand, if we don't want, then we need to work with strong ties. So this is one of the beautiful tool, and also simple to some extent. We are able to include any complex components into this so that this can be used effectively, more effectively. So such beautiful tie classification is very, very important in many cases. So, as I told you, we need to define or we need to find the upper and lower limits for all the cases. Now we have this theorem. We have considered one directed hypergraph with n vertices. Then the minimum number is equal to the number of vertices which has in degree greater than 0. So we have defined the lower limits here. Number of edges. I told you already, the number of edges plays a very vital role in complexity theory. If the number of edges are more, if it grows exponentially, then it is very difficult for us to tackle the problem. So we have defined the lower limits This lower limit is nothing but the number of vertices which has in degree greater than 0. So we have proved using distance between the hypergraph using the mathematical induction. I hope we know very well. So we can skip the proof here. Only some ideas are given to prove this theorem. Now, if you look at this theorem, we have fixed the upper limits. The maximum of hyper edges will be equal to the betweenness centrality greater than 0. So for this also we need to go for different centrality measures. So the number of edges that are having centrality measure, the betweenness centrality greater than 0 will be the maximum limits. In this case also we have used the principle of mathematical induction to prove the upper bound. Here is one simple social network. It is the network of football match. That is the football match between Spain and Dutch. Sorry, some if, many components are included in one, so some part has gone down. If it could be otherwise, we can make use of continuous so that we can roll a little more. We can make use of continuous thing. Not here, I think. In the PDF. Is it possible for you to go a little more? No. So that you'll be able to see the numerical of this. Okay. Okay, let me see, and in the meantime, we'll just try to look at this. So this diagram is the one, yeah, now you'll be able to see, right? So this is the one which depicts the pass between player to another player. So same player may pass the ball to many other players, and if you want to depict or represent using graphs, this will be more complicated. So this is the one for Spain, and this is the one for Dutch. Now, the number of players are going to be 11. So the number of vertices will be 11 in both the cases. Absolutely, there is no problem. If we construct as a graph, this network requires 38 edges for Spain and 25 for Dutch. Whereas if we represent the same with the help of hypergraphs, then we need only 10 hyper edges and 9 for Dutch. You can see the number is reduced to less than 50%. So this is the greatest advantage when we are representing using the hyper edge and without any loss in the information. So every information is available, and also the number of hyper edges are very less. So we can find out degree centrality. This is the degree centrality for the case of graphs. So 3, 2. We could not classify the strong and weak ties, whereas when we are using the hypergraphs, we will be able to classify the strong and weak ties. Like there are 3 strong ties for Spain and 5 weak ties for Spain. So this says that once we have identified, then the player in weak ties
prediction.
will be able to pass the ball effectively. Similarly, we can see for Dutch also. We have only two big times in case of Dutch. Obviously, you understand that Spain has won the match because it has five league ties. The history also the same that the Spain has won the match. So these type of analysis will be easily can done with the help of hypergraphs. Next. Yeah. So with one example, I am moving to biological networks. Uh, Biological networks will be the networks because of the relation between genes, proteins, um, all biological entities. Because it's a very complex system that any biology will be having, like neural networks, etc. So they are complex in nature. Any network we take like protein signaling, metabolic pathways, and disease mechanism from protein and etc. All these are much more complex in nature. We need to understand the structure first. We need to define the function, and we need to understand the dynamics of living systems with which we can do wonders in natural, in the life. So, for understanding the biological mechanism means we have to investigate gene regulation, protein-protein interaction, pathways, more specifically metabolic pathways, etc. These are all used for drug discovery and the development. This drug discovery can be computationally first identified using understanding the biological mechanisms. With this, we will be able to tailor the treatments once we get the gene and gene engineering. We can go for specialized treatment also. For that also we need to understand DNA network. Okay. So with this, we can design novel biological systems and pathways for industrial, medicinal, and other life related protein. Okay. Now we are going to discuss some of the examples, and we will discuss them in detail. One very interesting network is protein-protein interaction network. So these protein-protein interactions are a natural phenomena which is to be understood by us for various purposes. Then we have gene regulatory networks. They are the networks that is depicting the relationship between genes, controlling gene expression, etc. Metabolic networks also we have that are representing biochemical reactions. These pathways are very important for reaching or analyzing the disease mechanism. So we will be considering one network that is protein-protein interaction network. Normally we call it as PPI. So we are trying to find out the functional modules and the key proteins using the hypergraph with two or three methods which we are going to discuss. So one simple or basic method is clustering coefficients. These are all methods that could be easily obtained by some expression, mathematical expression like number of edges between neighbors with, when it's a ratio between number of edges between neighbors to maximum possible edges between the neighbors. Let us consider P3. Now, the neighbors of P3, if we talk, are P1, P2, P3, P5. Neighbors of P3 are all other. Now, if you, the number of edges between the neighbors, if we talk, for P3, there are two edges. See, the first one will consist P3, P4, P5, and the other one will be P1, P2, P3. So we have two in the numerator, and all maximum possible edges. So maximum possible edges will be 6 in this case. So one will be this, 2, 3, and from P3, how many possible edges, maximum possible edges, if we look at it, then there is one possible edge for P1. If we take for P2, there are two possible edges. Similarly, for P4, there are two possible edges, and P5 for one. That totals to 6. So, CCF of P3 will be 1 by 3, and the same will be for P4 also. That is also was 2 by 6. It is going to be 1 by 3. The conclusion of this is the one with the minimum CCF will be having interaction with many compared to other vertices. So here you can see P3 and P4 will be able to communicate to maximum number of vertices compared to P1 or P5. You can see P1 and P5 are at the end. That does not cover P2 and P4. But we take P5, this is not going to cover P2 and P1. Similarly for P1. So maximum coverage will be with P3 and P4. So this is how we are able to find the possibility of maximum reach. The other one is hypergraph entropy. In the beginning, we were discussing that hypergraphs could accommodate the uncertainty also. So we are trying to accommodate the uncertainty here. There are 5 vertices in total. So for edges also in total 5. So for each edge, the probability will be 1 by 5. This probability is included and they are summed to find the entropy. We can make use of advanced probabilistic distributions and other concepts also to include this, so that we will be able to find the entropy of any hypergraph. This entropy gives us whether it has most probable appearance or not, whether most probably it could do or not. We will be having some threshold value, and if it exceeds the threshold value, then the probability of the network will be very less. That is, probability of spanning the network is going to be very less. Even with this, we can see that it is 11.61, which is much more, and this is the entropy is very high in this case. So, in identifying the influential nodes of biological networks, we can use other seniority measures also. And And many biological networks, more specifically speaking, protein networks and all, are undirected. And some of the biological networks are directed. So we can make use of directed hypergraph for the analysis of biological network. We can make use of centrality measures also for the same. Yes. Okay. So here is one simple algorithm, not simple, actually this one algorithm. This is the algorithm which has the network as its input, and this algorithm will give us or classifies strong and weak type. We have four procedures to have strong and weak type classification. The first one, we need to construct the directed hypergraph. It is given as separate algorithm. Then we convert HDT into, that is directed hypergraphs into weighted directed hypergraph. We are seeing weights for them. Then we will be using, have used the genetic algorithm for the weight tune. We have to tune the weight, for which we have used the genetic algorithm. Then the weighted degree hypergraph will be classified with the degree centrality. We will be applying the degree centrality. Except genetic algorithm, the complexity of the algorithm 1 is going to be big O of n into m, where n is the number of vertices and m is the number of hyper edges. So this comes into polynomial time algorithm, and hence we can grow the data to any extent, to the maximum extent. The construction of directed hypergraph is given here. So we are going to construct hyper gauge, that is a directed hyper gauge, as we have already discussed with the tail and head. So if any protein is interacting with any other protein, say from A is interacting with B, then A is going to be the tail, which is denoted by VI, and VI plus 1 will be the head. So if there is any communication, we will be able to define an hypergauge. In the meantime, VI may communicate with more than one vertices, V, J, V, K, etc. So this hypergauge will have a tail VI whose head is going to be V, J, V, K, or how many, whatever it is. So in this way, we will be able to construct the directed hypergraph. And in this case, definitely the tail and the head will be more, and it cannot be neither B hypergraph nor F hypergraph. It is going to be BF hypergraph. Both backward and forward will be there. So it is definitely going to be BF hypergraph. So this, at the end of this algorithm, the given network is converted into directed hypergraph. So now we need to assign the weights. So initially, the degree is assigned as the weight for both vertices and edges. That is what is given in the first line. So the weight of Vj, every edge, will be added, increased, based on the number of edges that incident with that. So the weight is basically going to be the degree in the initial stage. So this degree will be tuned with the genetic algorithm. Well, initially we are going to have the PT as 0. We will be generating the populations at random. Fitness values also will be calculated, we will be shared with that. So till the termination conditions, we will be choosing the best individual from the group of population. So there are three operations for genetic algorithm. The first one is selection, then crossover, and then mutation. Finally, the selected population will be checked for fitness values. Here, previous one. Here, the selection is done by consecutive roulette wheel and also the rand. See, the roulette wheel selection will be having some of the what is weak and weakness. In most of the cases, you may get the same value. So to avoid we combine the ranking also. So roulette, ranking, and then roulette ranking. So these type of repeated things will give us real random selection. And we have used single point crossover for crossover, and also the uniform mutation to the resultant population is applied. Finally, we will be checking for fitness values, we checking along with the fitness values. Once if the present population has better fitness, then it will be taken for the next step. So we will be using it for 500 times, so I'm so iteratively to find the feasible solution. So finally, this genetic algorithm returns the feasible solution. Now we have weighted hypergraph that is obtained from the previous step. We are going to identify strong tie and weak tie nodes with the simple mechanism which we have already discussed, like mean and SD. So if any weight is greater than the sum of mean and SD, then it is classified as strong tie, and on other case it will be classified as weak tie. So with this, we are able to classify the nodes that are strong and that are weak. Yes. Yeah, we need again certain results like minimal hyper edge and the proof of this. In this case, we can see that it is based on B hyper R. Okay, the minimal hypergraph for every hyper edge is based on F hyper R. So we will be using B hyper R and F hyper R to find the minimal and maximal values. It has been proved there. Yes. And these are the results which we have obtained. Like we have taken many biological networks, then nodes of the biological network in case of hypergraph, number of edges, and here you can see the range of weighted hypergraph, uh, whose range of weighted nodes with the parameters mean and SD. This is going to be weak type. I think some mistake. One is going to be weak type, another is going to be a strong type. As I told you, when we run for a number of times, the number of weak ties and number of strong ties will slightly vary because of probabilistic nature. So we have mentioned the range. So here in the case, the number of weak ties will be from 400 to 450, whereas the number of strong ties will be from 470 to 530. So this has been checked for various biological networks. So you can see the number of strong ties and number of weak ties are much more. Here is the 3,420 to 3,490, whereas the strong tie will be from 3,900 to 4,150. So this tells us that we will be able to use these weak ties for the specific purpose and strong ties for another set of specific purposes. The same influential nodes were identified with the help of synchrony measures for various bionetworks. So the previous one with the previous method, here it is going to be when we have used centrality measures like degree centrality, CG, HG, all these things which we have discussed already. Here the number of edges are given here, number of vertices, number of edges, degree centrality for each biological network. Yeah, in this case, we have compared the influential proteins taken from COVID-19. See, from the COVID-19, the proteins of COVID-19 have been taken as the source, and host proteins are identified. We have tried to find out the pathways of each COVID-19 protein, and we identified the number of proteins of the enzyme that is causing any specific disease. TMPRSS2, actually in our data, we have totally 47 proteins, and all the 47 proteins are identified as strong proteins, mean to say that influencing the COVID-19. That means it receives the proteins of COVID-19, and that is going to cause the disease because of the enzyme TMP or SS2. Similarly, we have AS2. Almost all the proteins related to these enzymes that causes the disease because of the COVID-19 have been identified with our algorithm. So it is sure that the algorithm which is devised is more powerful than any other previous algorithms. So this is the comparison between arcs and hyperarcs count. As I told you, we can see that the number of arcs, that is number of edges of the graph, is as much as 7,62,822 as against 14,692 hyper edges. Yeah.
The time is 5 minutes. And it is 5 minutes again.
Only 5 minutes.
Okay.
Only 5 minutes more. Okay. Yes.
5 minutes more.
5 minutes more. Okay. Okay. So similarly, we can see the comparison of centrality measures between graphs and hypergraphs. To be able to find the steady, linear graph for strong tie and weak tie, but it is highly nonlinear for the case of graph. So we can make use of properties of hypergraph also for the analysis of biological networks. One of the prominent property is the unimodular hypergraph. This unimodular hypergraph can be used effectively in different ways. One of the way here is we have constructed the directed hypergraph as we discussed earlier with the tails and heads. Yes. And here we have used, we have devised a depth first search. This depth first search identifies the paths to the nodes from the source. So with this, we are trying to establish the paths till the end of the protein. That is, we will be able to reach maximum protein. Now here we are constructing the unimodular hypergraph. In this case, the unimodular hypergraph is the one which is giving the unimodular matrix. So any hypergraph that is related to unimodular matrix is unimodular hypergraph. So the zeros and ones are assigned based on the number of enzymes related to each and every protein. So it becomes complete unimodular matrix. The hypergraph that is getting out of the unimodular matrix is going to be unimodular graph. Here, another important thing is dimensionality reduction. The matrix which is obtained may be very big. So to reduce the size of the matrix, we will be using special operations. So the operations are minor hypergraph operation. We can remove the vertex. We can contract the vertices. We can add the hyper edges with contracted vertices. And because of this, we will be able to remove the sub-hyper edges. So while doing all these operations, the size of the dimension of the matrix is reduced to the smaller one. So these operations are shown here. One is R operation, another one is plus circle operation. So the matrix which you have taken is reduced to the smaller one. We can take any big with the help of these operations. You will be able to get a very small matrix also. And here are how these operations work on hyper edges is shown here. So this is the given matrix. So the hyper graph that is related to the given matrix is this. And finally, for the reduced matrix, we have the hyper graph which is reduced in the same way. So again, for the dimensionality reduction, we need to define the dimensions, and that has been proved with the logical operators we have used for the dimensionality reduction like R and plus circle. So the original use of reducing to unimodular matrix is clustering, grouping, or finding the path. So here we are trying to cluster it to identify the enzyme related to protein. So the clustering is very important here. With this clustering, we are able to identify the enzymes. The comparison is given here of the influential protein for various diseases like Parkinson's, diabetes, and COVID-19. As we got earlier, we are able to get almost all the proteins that are influencing for the diseases from the COVID-19 proteins. So this is for diabetes mellitus. Their representation here for Parkinson's, we are able to cluster into two using the unimodal matrix. You can see it is a 0, 1 whose determinant value is either 0 or 1. Here we don't get the case of -1. So this is the unimodal matrix for the case of COVID-19, which we have obtained, and this is a unimodal for diabetes mellitus. So clustering also has been shown here. We can make use of unimodal matrix for clustering the proteins, by which we are able to find out the path by which it moves from the origin from to the protein at the end, which causes or which is the part of the enzyme that causes the disease. So it reveals the hidden pattern and structural characteristics very effectively. We are able to understand the network dynamics and behavior. It is basically interdisciplinary collaboration for innovation of any other department or any other interdisciplinary sciences also. We are able to develop new algorithms and tools that will be impacting the social society directly. We have many future research also, possible future researches also. So these are the references. Thank you very much.
Thank you very much for giving us informative and interesting session. And gentlemen, now come to the question and answer session. I'd like to have 3 questions from the participants. Please raise your hand if there is any question. Or if there is a question from online participant on Zoom, please unmute your microphone and your question.
Ya, tanya.
For and your
we are waiting for them to ask, maybe I can.
This is serious from biology. I've been talking about the AI, so they know.
We have a demonstrative plot for monitoring of the plants, because we have, what you call Capi Jawa, it is certain species, plant species that used for the different for medicinal plant and also to improve the income of the farmer. If we want to integrate it between the hypergraph and the indicator of the maturity of the species, so it can be used to monitoring when they collect the seeds and when we prepare for the production or etc. Something like that.
Yeah, it is possible, we can work very well. We need basic data for these things like the statistics I can call, the existing one we can use. And what are the, I mean, what way we are going to work, whether we are going to work in the DNA level or protein level or so that part must be cleared. So you must be clear with that.
Okay. Do you mean from the biological parameter?
Yeah.
We converted into mathematics?
Yes, exactly. Yes.
Okay.
So biological parameters are basis. With biological parameters, we will be able to construct such networks we can call, and we will have to use the suitable property for computational things, and we can then what we can call it as test initially. The advantage of this is we need not have to go for various tests. So we can identify the specific point. We can work towards that.
Okay.
So
For example, like a color, for example, it is red, reddish, or chocolate, for example. So we have to put the number.
yeah,
Oh, I see.
yeah.
The parameter to convert.
Yes, exactly. So suitable or proper parameters are required. That must probably include all biological characteristics. So that must speak biologically. Then the computational output will be more accurate.
Thank you.
Thank you. There is any question, please.
Maybe working on smart farming.
Smart.
I think when we start to grow up the seed, then we need to design the planting layout.
Okay.
And so far, the farmer or pedestrian so only use the grid as a planting layout.
Okay.
So this is just a very basic application when we try to implement the planting layout based on a graph representation, then we have any type of planting layout.
Yeah.
For example, in the forestry, when you want to grow up the coffee forest, for example.
Okay.
And even one as well. Normally it doesn't use a grid as a graph.
Okay.
So I don't think we need a hypergraph in this case.
Okay.
only a graph. But actually, we have a lot of type of spatial graph, like, for example, apart from grid, like path tree, and also cycle, and also rail and everything. By using this kind of planting method, then we can apply very variety of conceptual graph, for example, dominating set. Yeah, to capture, to collect a soil moisture data. So when we want to know the humidity, for example, also we can use a dominating set. Even we can combine with resolving dominating set. By using also under the implementation of a smart sensor, we can also collect the data from those type of updates because we already were determined by using the data meaning for dominating set. Then the data will be fed directly to a computer using a specific platform. Then it is a big data. It is a big data. Yeah, when you saw the weakness of a graph, actually, when we integrate the graph with using the very smart sensor in our data, then we can probably a lot that is really that. So even by using this one, then we can develop graph neural networks. Yeah, so far, because artificial neural network, the source of the data is just like Euclidean source, or the what in terms of graph sources. So we have already this. So using also combining with the metric dimension, because in metric dimension there is like a resolving set, something like this, which is very unique and different with other practices. Then we can use this code to be a specific about the special code in such a way it is not overlapping with other practices. When we try to analyze those practices, every distribution of like in what delivery design system, also supply chain management and everything. So we use and use so hypergraphy is so very interesting for us because instead of having only two vertices in one edge, you can have more than two vertices in one edge. And then you call hypergraphs. But my question was, do you have any like very anti-hard problem? Instead of calculating the certain formula is like eccentricity, radius and everything, we already have this formula. So do you have any open problem that we can do during your stay with our student? It's like yesterday I already developed the new definition of aid anti-medicness of hypergraph. So maybe we can start with this one. Especially just like yesterday that we talked about the DNA engineering, maybe we can start with this one. What is the open problem? Especially, which is very fundamental and very so maybe we are not dealing first in the using coding or something because it will be more complicated. Just like deriving landmark or landmark and proving something, I think it will be better. And we just made a scratch paper to do so. Thank you, brother. Okay.
We do have such problems in hypergraphs, like hypergraph functions is
Okay.
one problem. Many people are working on it.
Yeah.
It's a widely useful problem. It is still to be solved.
Okay.
It is the application solved for specific applications, but in general, there is no algorithm that gives you the translation. Particularly for hypergraphs, it is going to be very vague. The thing will be more complex, and the still it is can be hard. So finding transversal for graph or any class of graph, that is still open, and the problem which we can start with.
Oh, no problem. Okay, thank you. Okay, yang lain ini. Pakai bahasa Madura kan?
English Jawa.
So do you want to show something that you said before you present your participants? Okay, just show us. It is in video in YouTube or
No, it's not in YouTube.
in your Twitters? Yeah, okay, bye.
Okay, thank you. Please give applause for. Ladies and gentlemen, the final result of the just lecture. I have to speaker for the informative and presentation, and all of the participants for very participation. Finally, once again, give the applause for the speaker and from you all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum. I will return to the audience.
Assalamualaikum ya. Jadi ini yang saya ajarkan kepada kalian tentang gelap. Ya, kalau gelap itu hanya ada satu sisi, hanya mengandung dua titik. Ya paham ya. Ini hypergraph. Satu sisi bisa lebih dari satu, apa dua titik. Nah, bukunya sudah saya berikan. Itu ya, dua buku. Itu dari apa superior karena dan harus sepanjang ya Pak itu tadi juga menemukan dan itu sangat menarik rasanya belum pernah proyek ini lokal ya rasanya belum pernah nah coba dilihat sehingga ini saya sangat apresiasi sekali karena untuk mengantisipasi adanya machine learning, artificial intelligence. So the graph concept of only graph is not enough because the data is very unknowns. The data also very big, and even the data is not in the form of Euclidean line. Ya. Kalau Euclidean line itu kayak geometri, ya bentuknya sudah jelas. Ya. Nah, tolong coba nanti masuk ChatGPT, masuk apa, jadi kalian punya banyak waktu untuk belajar tentang dia, sehingga dia adalah pakar dari kita. Oke, nah sebelum Anda bilang, rasanya silakan brother benefit can I ask the student if you they want to ask you to have a picture in your mind ya, oke ya, silakan betul ya, ya, juga ada temannya, ini bukan barang baru ini ya, kalau benar, kalau ya.
Orang bikin
Ya, silakan ya, paham ya, hubungan daerah pilihan sebentar. Ya, ya saya kira itu terima kasih. Ya, Pak terima kasih Pak.
dan kami juga terima kasih. Dan jawabannya ini menarik sekali karena saya sudah mencoba dengan disiplin anti-medium labeling dari Hypergraphs. Sudah, paper sudah jadi, paper sudah jadi. Ya, nanti kita ada. Baik, rasanya itu ya Pak Rizky ya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Ayo silakan.